I would like to welcome Professor Chakradeo for accepting our invitation and coming over here. I am also thankful and welcome to Barve sir, Vishwajit sir. There are two Barve sirs here. Dr. Barve, who is former principal of KK Engineering College. PP Joshi sir, who is the guest for today's function. Then all the teachers of Bhosla Military College and dear Ramdandis. I welcome you all in this workshop. Before going to the details of this workshop and the theme of the workshop, I also thank to our management of CHME Society and the principal of this college for providing financial support as well as allowing us or permitting us to conduct this workshop. The theme of the workshop is known to you, it is in front of you, it is on the screen. The joy of learning science through experiments. Why such a theme is chosen and why such a guest speaker is chosen for the theme, you'll come to know soon. Basically, nowadays there are too many classes of 11th and 12th science, they are connected to the colleges. And there, main thing is missing that they go for the practical twice or thrice within a year. And that is a fact. I know that when the student come to first year or even the first year engineering, I'm not talking about you, but from other colleges who are joining the colleges like Allen and so on. Since they are attached to the college, they are going to conduct the practicals, 3 to 4 practicals within a single day, which is not possible to grasp for you, as far as my opinion is concerned. When such students, they go for the engineering, they even not to hold vernier caliper or micrometer screw gauge properly. And this is a fact. One cannot ignore it. So how to handle the instruments? When you are holding the screwdriver, how you hold the screwdriver in your hand, how you hold the soldering gun in your hand at the time of soldering, that denotes, that specifies your skill. So experimental skills are to be enhanced. Basically, the beauty of physics or the chemistry is the practicals or the experiments that you are doing in the laboratory at the same time what sir are going to perform at this stage. हे सगळे जे आपले एक्सपेरिमेंट आहेत, या एक्सपेरिमेंट मध्ये काहीतरी शिकायचं असतं आपल्याला. वी वॉन्ट टू लर्न समथिंग. Generally, what happens? Why to find out surface tension? Why to find out the Young's modulus, bulk modulus, modulus of rigidity, Poisson's ratio? Your teacher used to say, "We want to find out today so and so thing." You don't know for what purpose it is. Actually, there is tremendous practical purpose. Even the medical instrumentation or the doctors cannot move ahead single step without the diagnosis. And all the diagnosis tools, all the instruments, they are made by the physicist. There is a tremendous application area of this subject, that is physics, but are you aware of that work or not? That is the question. So the purpose of today's workshop is to get acquainted with the skills, with the experiment that are known to you. You are actually finding out all the things, but these experiments you can sit at your home also, as sir has done. I think in 2008 we called the sir. 2018ला आपण सरांना एकदा बोलवलं होतं. त्यानंतर खूप दिवसापासून माझ्या डोक्यात होतं की सरांना बोलावं आणि त्यांचं लेक्चर ठेवावं की जेणेकरून तुमच्यापर्यंत या सगळ्या गोष्टी पोहोचतील. Since most of you are ND aspirant, basically the skills are important. So through this workshop, what you are getting is this is the interactive session. It is a dialogue. It is not the monologue first thing. Sir is going to use the dialogue system for this workshop, and it means that for every question, whether your answer is wrong or right, you are supposed to answer. If the answer is wrong, you'll come to know whether the concepts within your brain they are going wrong. कुठल्या दिशेने कन्सेप्ट आपल्याला रॉंग आहेत ते तरी कळायला लागतं आपल्याला. तुमचं उत्तर चुकीचं असो की बरोबर असो, देण्याचा प्रयत्न करा. Whether your answer is right or wrong, that doesn't matter. But try to answer. Okay. the demonstrations that are going to sir is going to perform, through that one, it is going to improve your creativity. When we use the word creativity, generally what happens, creativity means what? If you want to find out the height of the building, how you are going to measure the height? There is a need of meter scale. एक मीटर स्केल तरी लागेल, कुठली तरी स्केल लागेल, तरच तुम्हाला हाईट मोजता येईल, असंच तुमच्या डोक्यात असतं प्रत्येकात. बट इफ यू गो बियॉन्ड द बॉक्स, म्हणजे तुमचा एक ठराविक साचा आहे, त्याच्या बाहेर जर तुम्ही आलात तर तुम्हाला कळेल की फिजिक्स इज हॅव्हिंग ट्रेमेंडस नंबर ऑफ ऍक्शन. इफ यू हॅव गिव्हन अ स्टोन and mobile is in your pocket, you can start the stopwatch, you drop the stone from the heighted building, you can measure the height of the building with the equation S is equal to ut plus 1/2 at square. So creativity means this one. With the help of barometer, you can measure the height, because pressure changes with respect to height, that is known to you. So there are tremendous ways to find out the answer of a single question, even though you don't have meter scale in your pocket. Isn't it? So creativity is to be improved, and it can be improved through such a guest lectures, through such a workshops that is going to help you for solving the problems even in the physics. It is going to clear your concept in the physics. So clearing your concept, Newton's laws you might have studied. There are first, second, third laws. There are Kepler's laws. There are different laws in physics, but you might know that there are thermodynamics laws also. And in thermodynamics, there is a zeroth law. Why the number is zero? There is a big question mark. Why camels can walk easily in desert and why elephants can't? There are n number of questions that are present in your mind, because basically the physics is the science of question to yourself and try to find out the answer at your own. If not, teachers are there. Such eminent personalities are there, like Chakradeo Sir. This is also going to develop your curiosity in terms of physics. I think this is a brief introduction. With this brief introduction, I don't want to take much more time between Sir and you. So I will call Bhagawan Sir to introduce our today's guest lecture.
नमस्कार. व्यासपीठावरील मान्यवर and my dear students, before I give a brief introduction about our speaker, मला दोन एक गोष्टी सांगायच्या आहेत की ज्यावेळेस हा सेमिनार प्लॅन केला गेला त्यावेळेस इकनकर सर आणि माझी चर्चा झाली आणि मी सरांना म्हटलं की सर नाही, माझ्या विद्यार्थ्यांसाठी सुद्धा मला हा सेमिनार पाहिजे आणि मी हा स्पेशल तुमच्यासाठी हा सेमिनार अरेंज केलेला आहे, कारण की तुम्हाला सर्वांना माहिती की सगळ्यात कठीण सायन्स मध्ये काय जातं तर फिजिक्स. सगळ्यात कंटाळवाना सब्जेक्ट तुम्हाला काय वाटतं तो फिजिक्स. त्याच्या मागचं कारण काय की त्याच्यात इमॅजिनरी कन्सेप्ट खूप असतात आणि ते आपल्याला इमॅजिन करायला कठीण जातात. आणि हेच सगळे जे कन्सेप्ट आहे किंवा या विविध ज्या आयडियाज आहेत त्या जर प्रॅक्टिकली तुम्हाला पाहायला मिळाल्या तर नक्कीच तुमच्यामधल्या फिजिक्स विषयीची ती आवड निर्माण होईल आणि तुम्हालाही तो फिजिक्स विषय सोपा आहे हे तुम्हाला नक्कीच जाणवेल. आणि तशी हातोटी आजच्या आपल्या स्पीकर सरांमध्ये आहेत जे तुम्हाला इथे प्रत्यक्ष डेमॉन्स्ट्रेशन दाखवतील आणि हे इंटरॅक्टिव्ह असेल. एक गोष्ट अजून अशी सांगायची आहे की हे फक्त आपल्याला प्रयोग बघायचे नाहीयेत, तर हा इंटरॅक्टिव्ह सेशन असणार आहे. त्यामुळे सर काही प्रश्न विचारतील आणि तुमच्या मला जे जे उत्तर आहेत ते द्यायचे, ते चुकले तरी चालतील. लेखनकर सरांनी सांगितलं ते तुमच्यापर्यंत ठेवू नका. काय होतं आपल्याला वाटतं मला याचं उत्तर येतं, पण ते मिसअंडरस्टँडिंग असतं किंवा त्या चुकीच्या आयडिया आपल्या मनामध्ये रुजलेल्या असतात, तर त्या आपल्याला बाहेर काढायच्या आहेत. तुमच्या मनातल्या शंका ज्या आहेत त्याही बाहेर काढायच्या आहेत आणि हा सेशन तुम्ही पूर्णपणे एन्जॉय कराल याची मला पूर्ण खात्री आहे. सो लेट्स टर्न. आय विल हॅव द ब्रीफ इंट्रोडक्शन ऑफ अवर गेस्ट सर प्रोफेसर भगवान दत्तात्रय चक्रदेव. अबाउट सर's qualification. Sir is BSc MSc from Ruparel College Mumbai, BA from University of Mumbai and MPhil from Mumbai University. Dissertation work at TIFR. About Sir's experience, total 39 years of teaching experience, which includes 5 years in high school, 1 year in junior college, 33 years in degree college. And Sir retired as head of Department of Physics and Associate Professor from CHM College, Ultrasonic. At present, Sir is now President of Marathi Vignan Parishad Amarnath branch. Active worker for the cultivation of science in society for the last 50 years. अनुभव किती दांडगा आहे याचा आपल्याला अंदाज येतोय याच्यावरून. Worked as an observer, center in charge on behalf of TIFR for the national level physics Olympiad exam. Let us have some idea about the stage shows जो तुम्ही आता प्रत्यक्ष अनुभवणार आहात. This stage show is full of innovative and fascinating experiments in science, mainly physics. Duration is generally 2 to 3 hours and you are going to enjoy it. I am sure about that. Let us have some idea about the audience. High school audience, then junior college students, degree college, postgraduate, research scholars, general public, and it is open to all. In one attempt, generally the audience of 200 to 400, Sir can handle it very easily. Generally we find it difficult to handle 50, but Sir can handle around 400 audience in one glance. His guarantee, the audience will be spellbound for the full time. He is having a mobile laboratory packed in 9 to 10 bags. To my left hand side, you can see all the equipments are there, and you are going to see all those how they are working. Carry those in their rental car along with their team member. 3 to 4 team members are there. He has conducted more than 3,000 stage shows, so you can see the number in various schools, colleges, universities, institutions, clubs, etc. Almost all over the India except northeast states. People, they enjoy learning science through the experiment. So this is a brief introduction about our Sir, and I will not stay for a longer time in between you and Sir. So I thank you, Sir, for accepting our invitation, and we are going to enjoy all this experiment. Thank you.
Ready, go!
Before we begin, before we proceed for the function, I would like to felicitate Dr. Barve sir, who is the former principal of KK Engineering College, with offering flower. May I now request Barve sir, Dr. Barve sir, to offer a flower to Chakradeo sir.
Post clap, ready, go!
मी पण तुमचे सेशन घ्यायला येणार आहे.
Thank you, sir. Team members are also helping Chakradeo sir throughout the journey, along with the presentation of the workshop. So I request Joshi sir to felicitate Barve sir from the team, Vijay Barve sir from its team.
Post clap, ready, go!
I request Dev madam to felicitate Vishwanath sir.
Post clap, ready, go!
I request Jagdish Bhausa sir to felicitate Joshi sir, who is the teacher of your Bhausa sir also.
Post clap, ready, go!
मला एक असा आनंद होतोय की सरांकडूनच मी फिजिक्स शिकलेलो आहे. सर मला HL ओझर टाउनशिपला शिकवायला होते आणि आज सरांचा सत्कार करताना मला खरंच आनंद होतोय. सर आहेत म्हणून आम्ही ह्या स्टेजवर आहोत. त्यांची जी तळमळ होती त्या तळमळीतूनच आम्ही शिकलो आणि आज मी तुमच्यासमोर शिक्षक म्हणून उभा आहे. सर, मनापासून आभार, तुम्ही आम्हाला घडवलं.
You can see the respect given by a student to the teacher. At the same time, छोटे जोशी सर पण आपल्याकडे आलेले आहेत, जे सरांचे चिरंजीव आहेत, आपल्याकडे स्कूलमध्येच सर्व्हिसला आहेत. त्यांचंही फूल देऊन मी स्वागत करतो.
Poster clap, ready, go.
Before we begin the session, one more thing. You can see all these are the physicists. इथे मॅडम पण बसलेले आहेत, इकडे सर पण बसले आहेत, इकडे वरती स्टेजवर सर आहेत, सरचं वर 73 आहे, आता चालू आहे 73 आहे यांचं. After a long travel, he is going to perform the show for 3 hours. See the capacity. डॉक्टर बर्वे, मला तुमचं वय एक्झॅक्टली माहिती, पण मला असा अंदाज की 76-77 नक्की असावं. 86 सॉरी, 86 इयर्स ओल्ड. सगळ्या फिजिक्स लोकांचा फिजिकल फिटनेस बघितला ना तुम्ही, खूप चांगला आहे. सो इफ यू वॉन्ट टू मेंटेन द फिटनेस अँड कंट्रोल युअर वेट, ऑफर इज फिजिक्स सब्जेक्ट, so that there is no question of weight gain for you. Thank you so much, dear students. Now I request Chakradeo Sir to initiate his show for you. Thank you guys.
हॅलो. मागच्या ऐकायला येते का? काही असेल तर डिफिकल्टी मला सांगा. ओके. तुमच्या समोर एक मशीन आहे बघा. या मशीनला म्हणतात एअर ब्लोअर. दिस एअर ब्लोअर इज ए व्हेरी पॉवरफुल मोटर fan and it throws the air at high speed. Now when I switch on this air blower, you can feel the air coming out by the fingers. Yeah. I am feeling force up to this. But the air which comes out goes into a diverging beam. It goes on spreading out, which is of no any use for my experiment. Because in my experiment, I require a focused flow of air, somewhat in one direction. So I make one attachment, you can call it nozzle, or like a hose pipe. And now, see the difference. Previously, it was diverging beam. Now, you can check. I feel very strong force up to this height. So on such air flow, if I keep a ball and leave it, what will happen? The ball will go high. Now how much high it will go? 1 meter, 2 meter, 3 meter, ceiling. Can you imagine? Will it go up to ceiling? No. But it will go to some height. And after going to that height, it will remain there or it will fall down. Why it will fall? It will fall because of gravity. Yes or no? Yes. Okay, fine. So you change the concept now. See, the ball doesn't fall. Ball remains. Great surprise, ball remains stationary. And this was a wonderful observation. And the problem, why it remains stationary, why it doesn't fall down, fly away, this problem was solved by a genius physicist, scientist called Daniel Bernoulli. And Daniel Bernoulli gave a very simple theory. He made physics very easy. Beginning, fluid mechanics. What he explained, the ball remains stationary because its weight is counterbalanced by the upward pressure of air. Common sense. But somebody asked him why the ball did not fly away, run away in this direction or this direction. He explained very simple, very simple. So simple that I teach this to primary students and they understand physics and they explain me afterwards, sir, this is the reason I know. See, this is the beauty of physics. The ball remains stationary because if the ball tries to run away in this direction, then air here is going at high speed. So when the air is going at high speed here, the pressure of air on this space is less. See the observation, see the theory. When the air is running high speed, here the pressure is less. And comparatively, the surrounding air from this side will have more pressure. So what will happen? The surrounding air will push the ball back to center. Now if the ball tries to run away in this direction, what will happen? Common sense. High speed, so less pressure, more pressure, so it will come back. So make a concept that the surrounding air will keep on pushing the ball always on one line called as central maxima line. So you can think, why? What is central maxima line? Central maxima line is nothing but the axis of this pipe. Because at this, in this direction, the speed of air is maximum. You may imagine graph. The graph will be like this. A sharp peak. And why sharp peak? Because it is nozzle. Very simple theory. But beyond this, I have done plenty of experiments on Bernoulli principle and I will demonstrate some of them here. For example, here, if ball is stationary here and I bend this pipe, I make this angle more and more and more and the ball will come here. Now my question is, will the ball remain here
No, sir.
or will it fall down? Why it will fall?
Angle of attack.
Gravity. Because the gravity force is this direction and air pressure is this direction. So common sense tells us that the ball will fall. But in physics, sometimes common sense becomes nonsense. You know why? They say magic. What magic? No magic. It is all science. I will show you magic. Okay. Ball will be stationary. Is it not surprising that the ball, how the ball remains stationary here? The gravity is vertically downward and the force is in direction. So now you have to think and apply your logic and understand Bernoulli principle. What Bernoulli said, that the ball will be pushed on the central maxima line from all directions. Are you able to understand what I say? I am trying to make it as simple as possible. But the ball will remain stationary here. But my further question is interesting. If I make this angle more and more and more and more, one situation will come when the ball will fall. Because the Bernoulli pressure has limit. And that limit is crossed. In that case, the gravity will dominate over the pressure. I hope you are able to understand what I say.
Yes.
I will demonstrate. So you have observed that when I made this angle of about 60 or 70 degree, from vertical 70 degree, it fell down. So up to that limit, the ball was in stationary state. And this is in one direction, so you can rotate all the way around and you can imagine a cone, and in that cone, ball will be stationary. Physics people understand cone very easily. Imagine, yes, very simple. Okay. Intellectual question now for NDA students. Huh? I'm testing your knowledge. I want your answer response by raising the hand. You know what is this? Kaun banega crorepati? You see, no? Public opinion poll, you see? I am taking public opinion poll after question, but let us see what is the question. Very tricky question. Ball is stationary. I bend this, it is stationary here. And now when it is stationary here, I play a mischief. What I do? I switch off the motor. What I do? When the ball is stationary here, I switch off the motor. What will happen? Most of the students will say ball will fall down. But I will give you three options for the ball to fall. Out of three options, one option is the ball will be thrown in this direction as a projectile because it is not in bound state now. Second option, the ball will have vertical free fall. Third option, the ball will fall slowly toward the pipe and then fall down. Wait, I want public opinion poll now. Opinion poll. No answer. I want everybody to answer. Now my first option is open. I say the ball will be thrown toward the ball in a projectile motion. How many of you agree? Raise the hands. Oh, nobody. Nobody agrees. Huh? One student is there. One girl is there. Okay. No problem. Even if you are wrong, no problem. Huh? Don't worry. Nobody is I'm going to hang you. Okay. Now I open second option. Second option is the ball will have vertical free fall. How many agree with me? Ball will have vertical free fall. Hardly 10-20%, 10% students. And very few girls, so many boys. Okay. Hand down. Now third option. The ball will have slow fall towards the pipe. Oh, great. Very big number of girls and boys also. Very good. The third option. You also have third option. Okay. Very good. Let us work out. Okay. Let us work out. Oh, really? So, I am very happy to tell that big majority of boys and girls, they are really having good understanding of physics. Because they selected the correct answer. So clap for yourself. So, your answer that the ball will come down slowly toward the pipe and will fall is correct. And now, one of you, please explain me why this happened. Anybody can explain me? Logic, yes?
So vacuum.
Vacuum, very vacuum.
जैसे वो फोर्स अप्लाई हो रहा था तो वो वापस के नीचे गया था.
सॉरी वैक्यूम नहीं है इधर. एक बात बताओ, ये ब्लोअर है, ये वैक्यूम क्लीनर नहीं है, ये बॉल को खींचने वाला वैक्यूम वाला नहीं है. रॉन्ग कंसेप्ट. ये ब्लोअर है, वैक्यूम क्लीनर नहीं है. एनीबॉडी एल्स? यस, स्पीक.
सर हवा अचानक से बंद नहीं हुई, धीरे धीरे.
Clap is right. Right? I'll tell you scientific answer. Huh? More elaborate. When I switch off the motor doesn't stop immediately, but it comes gradually slow down. Common sense. If you have a ceiling fan, you switch off. Does it stop immediately? No, sir. Why not? Why the fan doesn't stop immediately? Yes? There is very important answer that the fan has angular momentum, rotational kinetic energy. You learn physics but never think like this. When fan is in full speed, it has rotational kinetic energy and angular momentum. So that quantity tries to conserve itself, remain constant. But the fan gradually goes slow because there is some friction. Two friction. Number one, ball bearing. Number two, air friction. We never think air friction. Air also tries to oppose. So please observe this event once again and keep it in memory forever. See, this event is very important. Yeah? It came down on the line. And the reason, in my language, as long as blower is on, the airflow will be forcing the ball to float. But surrounding air will always try to keep the ball on the central maxima line. Where is central maxima line? This axis of the pipe. I hope you are able to understand now. I can see on your faces. Yes, are you getting my point? Now, my one friend asked me, you are switching off the fan. Okay, I don't switch off. I put a obstacle here and cut the airflow. Then what will happen? Then I said, second option is correct. The ball will have vertical free fall. Because if you cut off the airflow with the not switching off, but cut off the airflow, then it will fall. Okay. I hope you are able to guess what I am saying. It is not going to more height because of weight. But if I keep a ball of this type, it is not going at all. But if I keep a ball like this, now this ball went to very large height, but it cannot remain stationary, it falls down. Think why?
Because of like the influence of central maximum.
Because it is small size, lightweight, and even a small air current will disturb the ball. I hope you understand. A small air current will also disturb the ball from the equilibrium. That is what is common sense. But people ask, can you keep the ball stationary? I say, yes, why not? I can keep. You know what I did? I am having a speed control. It is called a RPM control. RPM means what you know, rotations per minute. And as per manual of this blower, the maximum RPM is 16,000 RPM. 16,000 means in 1 minute the motor will complete 16,000 rotations. For your information, our ceiling fan has hardly 200, 300 RPM. But it is 16,000. So much high speed. So that's why air blower is a powerful motor. Okay. Anyway, if you make the speed very low, it is stationary. Gradually increase, it is stationary. Still increase. Okay. Now this ball. I have a wonderful idea. This ball is smooth. very special. Huh? Very special. Now, when it is floating at one place, I will keep my hand above, like this, and I will bring my hand down, down, and down. So as I bring my hand down, my hand can never touch the ball. My hand can never touch the ball. I will show you demo. Now you can always think that when I bring my hand down, the air cushion is built up here and the air is going above will hit my hand and come back. You know what is that? Rebound. In carom we play rebound, like that, reflection. So air particles are thrown back and that is why air cushion is built up and my hand cannot touch the ball. Common sense. But many times people never understand common sense. For example here. One. Great. Two. Okay, fine. Now my question is, how two balls can remain stationary? Think about it. Apply your own logic. Apply your own idea. But I ask you the question now. I keep this person and then I keep this. No, it will not work. Why? Yeah. You apply your own ideas and try to explain yourself. But this is wonderful. I got two balls, identical, same mass, volume, density, weight, surface, everything same. Twins, identical twins. And I keep one and make on. Okay. Now if I keep this, okay. So I observe that both will be stationary at the same height. Now my question is, if I keep the two balls simultaneously, what will happen? Both will be stationary? No. Because if both are stationary, the air will separate them. Yes or no? So will they remain or fall? Both will fall or one will fall? Let us work out. Yeah. In physics, only one answer. Actually, do the working and then check. The two cannot remain stationary because there is one chair and two people fighting for the chair. Remember, it is politics. Yes. So one will have to surrender. Okay. Now I am showing you something new. Okay. Yeah, this is one ball which can spin, and you can see the spin very easily. Actually, I apply one heavy hook and the hook is downward and it keeps on rotating, but that hook has misplaced somewhere. Okay, now I will show you something difficult. Very difficult. Yes. I got this collection. 1, 2, 3. All three are massive, solid, very. You know what is it? Solid balls. And out of these three, I take one, is the biggest size, medium size, small size. Okay, number 1, number 2, number 3. I keep number 1. I keep number 2. No. Now number 3. Great. Big size ball goes up, medium size doesn't go up, and the small size goes up. I won't give the answer. You think about it. You have to apply your logic. This ball is very funny. Actually, this is aluminum foil. I made the ball and it never remains stationary because of rough surface. But this is bigger ball with rough surface. Like golf. That type of ball is there, but it is very lightweight. That is different. This ball can never remain stationary. It will keep on wobbling. It keeps on wobbling up and down because of the rough surface. Air will have friction. So I'm insisting about surface property. Okay. Anyway, last and best demo on Barnauli. I got this ball. I keep in tea filter. It remains stationary. Now I keep this filter inverted and keep the ball. What will happen? It will fall. Common. Now quickly tell me why it will fall. Why it cannot remain stationary?
The airflow is received.
Answer to the point. Yes, to the point. Yes, please. Thank.
So the airflow is not focused.
Huh?
The airflow is not focused.
Okay. I will give the answer. This ball is spherical and this is convex. So the contact is very small area. And center of mass should be vertically above it. Otherwise it will roll down. Why rolling? Spherical body has tendency to roll down because of gravity. You are not mentioning gravity. Expected gravity. So why it will go down? It is because of. But here it doesn't roll down. Why? Because this is concave. Understand? Same. Concave. Convex. Concave means, and if the ball tries to go in any direction, it has to go against the gravity, which is not agreeable by nature. What nature says, nature says that every body should try to remain at the lowest potential energy level. Basic physics. Every body will remain at, because this is not a living body, it cannot climb up. But if it is living body, yes. Internal energy is there, it can climb. Okay, that is. But I will show you magic. Oh no. Great. So even if I took this to this height, it was remaining stationary. Now think why. Why it was remaining stationary here? The reason is airflow. Bernoulli pressure. Understand Bernoulli? And most important thing, this ball was supported by the filter. My hand, my filter, that was supplying normal reaction vertically upward. Many people never understand normal reaction. I keep the ball on the table, it remains stationary because its weight is counterbalanced by the upward force applied by the table on the ball. Are you taught like this? Yes. It is very important that normal reaction. And my filter and my hand, they are supplying contact, normal reaction, and that is why it was stationary. Otherwise, it would wobble and jump here and there. But this is one funny thing I will show you. Okay. It remains, right? And now see the magic. What I done? I have done a very simple change. I applied some weight. In middle clamp. And this clamp, when I apply some weight. So the center of mass of this hole is low. And it is downward. So it remains stable. Are you able to understand what I say? It will not remain like this because it is lightweight, heavyweight. So heavy will be always downwards. And I can show you. Okay. Great. Now they are fighting. They are fighting for common sense. Okay. Anyway. Are you able to understand what I did? The two were having that stability problem. Anyway, did you like the experiment?
Yes, sir.
You can clap for me. Same mass, same volume, same density, everything identical, and I take one away and leave it. I observe that only one will get kicked out because of momentum and energy conservation, school level physics. Very basic physics. Before collision and after collision, energy and momentum will remain constant. Same. Now I take two balls. Okay. I take two out. I take three out. I take four out. Okay, fine. Now I take one from this side and two from this side and leave simultaneously. Can you imagine what will happen? 1 and 2. So 1p and 2p. What is the resultant?
P.
1p in this direction. So the person who doesn't know the real physics, he will answer that one will get kicked out. But the person who knows real physics, he will say that after collision, one coming from this side, one will go on that side, and two from this side, two will go out this side. So it is 1, 2, 2, 1, 1, 2, 2, 1 exchange. And that is what is wonderful. See, observe this carefully. Once again I tell, one from this side, two from this side. After collision, expectation is that only one will get kicked out on my right side. But it is wrong answer. See what happens. Observe carefully. See. I hope you are able to see last 2, 1, 1, 2, 1, 2. Okay. Now, same but slight difference. I take 2 from this side, 3 from this side, and allow them to fall simultaneously. What will happen? 3, 2, 2, 3. Oh, it is keeping on exchanging. Okay, fine. Now I take 1 from this side, 1 from this side, and allow them to fall simultaneously. What about middle 3 will happen? Middle 3 will not move. The middle 3 are remaining stationary. Now question is why? The reason is very simple. F1, F2. The two forces are equal and opposite. So net force is 0. And if the net force is 0, Newton gave very simple law, first law. What law says? Very simple law. There is no external unbalanced force acting on the 3 balls. So the 3 balls will remain stationary. So no force, no motion. Simple. No force, no motion. In nutshell. But if I take 2 from this side and 2 from this side and allow them again to fall simultaneously, what will happen to middle ball? It will not move. It will remain stationary. Okay. And that is what is expected. And using this experiment, this type of toy, Newton got the idea of inertia. Inertia concept came through experiments. Remember, Newton did a lot of experiments, but basic thing is that the inertia is that property which will be making the ball stationary if there is no external unbalanced force acting upon. But if the ball is already in motion, then it will continue to move in the same direction with the same speed forever. We never understand this because you kick a football, it goes long distance but it stops. It never continues. So why it stops? Common sense, because of friction with the ground, friction with the air. Yes. Understand physics is very easy. Very easy. In Newton's law, I will give you one wonderful demo here. Suppose I remove this, and I keep only 2 balls in picture. I take one away and leave it. What I do? I take one away and leave it. Can you imagine what will happen when this will come and hit this ball? Yes, anybody can answer my question? After hitting, what will happen? Yes, please answer. Raise your hand. Yes, yes. Start talking.
So the first ball will stay stationary, then that will move, and then
What do you say? First ball will remain, stop there,
stop.
and
Stop.
second will go out.
Yes.
And after that, what will happen?
Then it will come and
Are you sure about it? Are you sure? So this ball will have zero momentum, zero energy after collision. Yes or no? Are you sure about it? Yes, anybody agree with her? You agree with her? You also agree with her? Very good. What about boys? She is not correct. You agree with her? Okay. Okay. Some more students are raising the hand one by one, but you are right. Clap for us. I see you are working. Huh? But I'll tell you one statement. Very important statement in physics. Huh? And you should learn the statement by heart. Huh? Sit down. See, when this will come and hit, it will suddenly stop and it will go out. See this. Again, observe. When this will come and hit, it will stop. So law in physics is that hit and stop, not hit and run. You know hit and run?
Yes, sir.
Very few. Nowadays in newspaper it comes hit and run. But in physics it will stop. You know why? This ball will come and hit this ball, it will transfer all its momentum and all its energy to other ball. Now underline the word all momentum, all energy, and ask the question why all momentum, why all energy, and Newton gave the answer. He said because they have two equal masses. Masses are equal. And here I tell you one simple thing. A big ball is there and a small ball is there. A small ball will come and hit a big ball. What will happen? This will stop and it will go away. Yes or no? No. Tell me what will happen. Small ball will come and hit the big ball. What will happen? The small will go back. Yes, the small will go back. And what about big ball?
It will stay there.
No, it will not remain there. It will go a little bit up. It will go a little bit away. But I take reverse case now. I got a small ball, I got a big ball. Big will come and hit the small. What will happen? Ah, in that case, the small will go far away. And what about big ball?
Sir, it
It is,
will
wait. The big ball will come and hit and stop, or will come and hit and go back?
no, sir.
Go back. I asked the patient. My patient was tricky. My patient was, what about the big ball? Big ball will come and hit and stop, or go back? Stop. Wrong. Go back wrong.
So it will go with the
Continue. The big ball will continue to move in the same direction because mass. Have you played carom?
yes, sir.
In carom, when you hit a coin, sometimes if it is head-on collision, coin goes to pocket, strike also follows to the pocket. Tell me why? Because mass of the coin is small and mass of the striker is big. Anybody know what is mass of the coin and what is mass of the striker? Guess. Any guess? Why guess? Yes. You are not playing carom. Huh? No, you never think like that. Anyway, I'll give the answer. The coin has 5 grams and striker standard has 15 grams. So striker is 3 times heavier, massive. So when striker will hit the coin, if it is having sizable good energy, it will follow the coin and go to the pocket. We call it double dip. And if it is non-head-on collision, the coin goes like this, striker goes like this. Have you seen this? Cut. We say cut. Cut means it is non-head-on collision. I show practical examples here. Remember this. Remember one thing. Mass equal is very important concept. But now I ask difficult question now. Suppose I take both the balls away and allow them to fall simultaneously. Now what will happen? They will come and hit and stop. Yes or no? Yes. Yes or no? No. No. They will come and hit and stop.
Yes, sir.
Law in physics. Yes or no? Yes. How many say yes? Raise your hand. Okay. I don't blame you, but answer is wrong. They will not hit and stop, but they will go back. See this. Oh, beautiful. Now hit and stop. The law is wrong. I have proved it. It is not a law. It is my fake law. You see what happens here? They keep on banging for a long time. And why they are banging? Because energy momentum conservation. But observe carefully, their distance is slowly decreasing. And a slow decrease is called as exponential decay. Exponential decay is very, very basic concept in physics. Many people never understand discharge of a capacitor, nuclear decay discharge, then height of the height of water in reservoir, having leakage at the bottom. So many things. They have exponential decay. Now, what is speciality of exponential decay? No? Initially, it is very fast, but slowly it goes decreasing, and the graph will go to zero asymptotically at infinity. People can't imagine infinity. See, still they are banging. You know why? Exponential decay. It continues for a long time. I have counted hundreds of events like this. But the funniest thing is that initially large, it goes on falling fast. See the fall, see the decrease fast. And then slowly, asymptotically it goes to zero. I hope everybody is able to understand what I say.
Yes.
I'll go ahead. Okay. Now, I'll tell you one thing. I'll not talk much, but only one statement I make. In previous case, yes, hit and stop. It obeys. And now they don't obey hit and stop. Why? Why they don't obey hit and stop? Because in previous case, one was stationary and one was moving. And now in this case, so they are exchanging their momentum and energy repeatedly. Are you able to understand the word? See, physics is very simple, very easy, very interesting. But when you do experiments, if you do experiments, it is really interesting. I can show you hundreds of experiments, but I want to tell many things, but I will not waste my time on one experiment because I have a big collection. Only I show you some events. I will not talk, just observe and try to understand logic behind it. Have you seen the event? I have shown all possible variations. And in every variation, there is one basic statement, underlying statement, and that is momentum and energy conservation. Yeah. Multiple collisions, but the decay is fast. Why fast decay? Because many balls are making loss of energy. Anyway, can you hear? These balls are clapping for Sir Isaac Newton. Okay.
त्याचं नाव सांगा ना.
Newton's cradle. Basic.
न्यूटनचा पाळणा आहे तो.
झोपाळा पाळणा. Yes.
स्कूल होय काय ओके
I changed to magnetism. The ball is stationary, floating in air, and surprisingly, the ball is not falling down. It is floating in air. Okay, all are 11, 12 and higher level, so I don't waste my time. Common sense, the magnet is there. But where is magnet? Here or both? Can both be magnets? Yes or no? Can both magnets? Yes, both can be, but condition?
opposite
Opposite poles, correct. Now I take this, getting stuck up. What does it mean?
It has magnetic
But
properties.
wrong. It may be this is magnet, this is iron. So don't give guarantee by attraction. Don't give guarantee by attraction. The keys are getting stuck up doesn't mean all the time that this is magnet, this is not magnet. But it can be reversed way. The iron and his magnet. Attraction. Oh, attraction. So this is again one of them is magnet. But if I take both together, yes, they are attraction. That means you are having idea, right? Now, if you tell me, can you prove that both are magnets without using the keys? I can prove. How? I use my common sense. This is North Pole, suppose this is North Pole, and suppose this is South Pole, then you have attraction there. So what is the pole here? North. And if North is here and North is here, and I keep this, I bring it near, what a funny thing happening, you know. The ball is running away. Now why it is running away? Because there is strong repulsion. Because the neodymium magnet is hidden inside the ball. And this is what is basic concept that like poles repel, unlike poles attract. On this also I got magic. Fantastic magic is there. And you will be surprised how this can happen. How this can happen. But let me tell you one more thing about it. Very basic thing I will tell you. That between these two magnets, I pass a cardboard, tough, thick paper. People say school level that when I pass this paper, it will fall down. Why it will fall? Because the lines will be cut. What do you think? It will fall or not fall? No. It will not fall because the magnetic lines of force can penetrate, pass through, and it will not fall. So we say that this medium is transparent for the magnetic field. Remember the word. This medium is transparent for the magnetic field. Now I keep on changing the medium, and I got big correction here also. I got a thick, very double thick. You know what is this? Cheese box wrapper cover, and I pass it. There is nothing. Okay. Now I take a thick sheet called as bakelite. Very tough, very rigid material, hard plastic, and I pass it. Again, there is no effect, transparent. Okay, very basic concept. Now I take a thin, very thin metal foil, aluminium, and now I pass this foil. Tell me what will happen now. Now it will fall. Why it will fall? Because it is metal. It will cut the lines. But wrong idea. It doesn't. Why? Because it is transparent. It is paramagnetic. Okay. Okay. This is a thick, multiple folds. You know how many 8 layers? Foil. Transparent. I learn by experiment. I learn transparent. Okay. Now I take actual metal sheet, aluminum, and pass. Okay. Now I take a thick metal slab. Now this is aluminum and very thick. Now tell me what will happen. If I pass the slab, it will fall or not fall?
Not fall.
How many say it will fall? Raise your hands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Fine. So some people say it will fall. So remaining will say not fall. Okay? Assume. Now check out. Oh, great. I have passed the slab and the ball did not fall. What I learned? I learned very simple concept that thick slab of aluminum also is transparent. So those who have raised the hand, they should not forget that aluminum is paramagnetic. Okay? Very, very weak property. Anyway, I want to tell you one thing very important. I got a glass plate. I pass the glass plate. Tell me what will happen now. The glass will cut or not cut?
Not cut.
Not cut. Okay, the glass is transparent. But instead of glass, now I take a mirror. And my concept is that mirror will reflect. So I pass the mirror, it will reflect the magnetic field. So what will happen then?
It will not reflect.
The ball will fall. Yes or no?
No, sir.
How many say no? Raise your hands. No. The ball will not fall. Raise your hands. They are afraid. Huh? They are looking at the neighbors. Why you should look at the neighbors? If you have answer, you raise your hand. So these people say no. Okay, hand down. How many say yes, it will fall? Raise your hand. Yes, it will fall. Okay, fine, no problem. So those who are making mistake in answer, please learn. Yes, what do you want to say here? Yes. I was misguiding them. I was misguiding. You know, best way of guiding is misguiding. And tell them I am misguided. It doesn't fall. Surprisingly, the ball doesn't fall. Tell me why.
It's made to reflect light.
Because mirror is transparent for the magnetic field.
Not the light.
I hope people who are attending my demo show, they should have full concentration, because I'll tell you one simple secret about this mirror. This is a glass. Beyond, on the other side of glass, there is very thin layer of aluminium. What is the layer? Aluminium. And on that, oil paint layer is there. And on that oil paint, I applied one thin layer of Fevicol. And on that, I applied paper. Then I applied plastic coating. You know what? Multiple layers are there. Glass, aluminium, oil paint, then Fevicol, and then ordinary paper, and then plastic lamination. Yeah, mirror is laminated backside. So I used this mirror for 20 years. 20 years, no damage. You know why? Laminated, waterproof. People keep on wondering how we can use a mirror for 20 years. Only one old mirror was broken by one student. Otherwise, that would have lasted for 40 years. No problem. Anyway, I tell you physics. Mirror is transparent for magnetic field. Okay. Now, one of the best example, iron sheet. I take iron sheet and pass in the tap. Tell me what will happen now. Now the ball will fall, because iron is ferromagnetic, not transparent. Yes or no? Yes or no?
Yes, sir.
So how many agree with me? I say when I pass the iron sheet, the ball will fall. You agree with me? Raise your hand. They are still looking here and there. What others are doing? Okay, anyway. See the magic. It doesn't fall. Great surprise. But I will not say this is transparent. But I will say that this is happening because of the magnetic induction, or it is called as induced magnetism. Same word, magnetic induction or induced magnetism. Now people ask me question, explain me what is magnetic induction. I tell them in very simple word, nutshell. When I bring iron near a strong magnet, this also becomes a magnet. But how? If there is south pole here, I get north pole here, and I get south pole here, and this south pole will always attract north pole. Are you getting my point? Very simple. And such experiments you should never forget for lifetime. Yeah. Don't be having any attention diversion. Okay, I will give you something new. Always packing problem is there. Done. No waste of time. Okay. See, the magnetic pendulum is a very funny thing. Having swing, time period is the time required for one go and come back journey to and fro. So you can imagine that if the length is less, the time period is small. And if the length is more, time period is more. Depends upon length. Okay. What proportion is root, square root? Anyway, by the way, this pendulum and below this pendulum, I am going to keep one slab. What is this slab? Aluminum slab. Huh? Very funny experiment is there. And I have made the distance optimum a few millimeter, hardly 2 or 3 millimeter distance. And if I give the oscillations, it goes free, okay. But if I keep this slab, oh great. Surprisingly, the pendulum comes to rest immediately. Magic. And now I ask the question why? People say because this will attract the magnet. No. No. Wrong answer. Because this is ferromagnetic. The force between strong magnet and ferromagnet is very, very weak. It is almost negligible. Now my question is, anybody knows what is science behind it? The experiment. Why the pendulum comes to rest very quickly? Anybody knows? Yes? Those who are studying 11, 12. Has it studied eddy currents? Have you heard about eddy currents? No. Okay, I'll tell you. In simple nutshell, when you move a magnet over a metal, like aluminum or copper, dia or para or something, when you move this magnet over a metal, inside the metal bulk, there are plenty of current loops generated. They are called as eddy currents. And these eddy currents, they generate their own magnetic fields. And these magnetic fields will oppose the motion of magnet. It is a theory. Theory is that when I make the magnet to move over the metal surface, it stops suddenly. I call this as magnetic brake. I call this as magnetic brake. Now, how magnetic brake works? The magnetic brake is like magic. It is like magic. The brake is applied without contact, without friction, without heat, light, sound generation. No heat, no light, no sound, no energy waste, and suddenly the pendulum stops. Now, this is eddy current effect. I'll not go in deep and deep because I got many more things to show. But in 11, 12, you'll learn about this. At that time, you'll remember this. Or you can.
Why rotation doesn't stop?
Yes.
Why rotation doesn't stop?
Rotation doesn't stop, yes. Axis, yes, it is different. But it is rotating, that also will stop, but slowly. That also will stop. It will also have effect, but it will take time to stop, yes. And rotation is because of the twist in the string. The twist in the string is from here to here. So I'll think about it, but it is having something axis relation, magnetic field axis relation. But the current loops are generating their own magnetic field, and that will oppose the motion. That is what is eddy current. Now, I ask one simple question. Instead of keeping the slab like this, I keep like this. You know what is this? Perpendicular. And tell the pendulum to go. Oh, now I observe something different. See? It takes more time. Tell me why. Tell me why. If I keep the slab like this and it stops within 2 or 3, but if I take like this, it will take more oscillations and then stop. Common sense. length, contact, connections, yes, okay. Here. Now, one difficult question. I will not give the answer. I will not give the answer. You have to think about it. Huh? My question is, in steady state, I take the slab away. What will happen? Now, in steady state, I take the slab away. See what happens. Oh, great. I have not touched the magnet. I have not touched the pendulum, but the moment I pull the slab, this comes along with it. Now tell me why. Not easy. Not easy to answer. You have to think about it, then you have to apply logic. Okay? No idea. I will not give the answer. I have given the question, and it is for you to think, ponder on it, and give the okay. Yes. Now, I am having another wonderful experiment. I got steel ball. I got again steel ball, stainless steel. And these two balls I am hanging from the nails here. One and two. Okay? Wonderful. So this is, I got two steel balls hanging parallel by threads, and they are just touching. And if I take one away, oh, I see beautiful cutting. See the event. Head-on collision. And this is non-head-on collision. Non-head-on collision, see the effect. Non-stop collisions. Non-stop. Very nice example of conservation of energy momentum, and they are not stopping at all. Surprising. But after long time they stop. Common sense. Again. Now if I take one away and make a distance of about 1 centimeter, how much is the distance between them is 1 centimeter. And I make the air between these two balls to flow in this direction. Blow. But to blow this air, I got very simple mechanism. A balloon, marker pen. I can blow the balloon. Okay. I got very nice trick. I can stop the balloon to float. See the application of material. Scrap, throw away ball pen, marker pen. And I use this airtight. It is airtight. And I remove the internal parts and made the hollow. And this is my pump, air pump. And if I blow the air like this, tell me what will happen. Any boy, any girl, yes? Imagine what will happen. If I blow the air, what will happen? I'll give you options. Options are the ball will go away, number one. Nothing will happen, second option. Third, ball will come near.
come closer.
Option number 1, ball will go away. How many agree? Okay, you agree, ball will go away. Second option, nothing will happen. How many agree? Some people raise their hands. Okay. Third option, the ball will come near. How many agree? Very poor response. They are not getting the answer. I think, yes, you want to say they will come near?
Yes, sir.
Tell me why.
Sir, because when the air will go, so it will pass from the both the side. So the balls will come together.
Not to the mark, yes?
सर हाई स्पीड मतलब जब हवा पास करेगा तो हाई प्रेशर क्रिएट होगा उसकी वजह से बॉल
हाई प्रेशर क्रिएट होगा तो दूर जाना होता है. They will go away.
Think about the first experiment he has shown.
it will create high speed low pressure. High
High
speed.
speed, low pressure, you are right. Clap for it. Okay, let us work out. Observe carefully and work out. Have you seen? When I blew the air, the balls came together. It is Bernoulli principle. What Bernoulli said, when you pass the air, the pressure will be less, surrounding will be more, so they will come near. Now one of my friends was asking me, if you pass the air vertically upward, what will same thing happen? Whether it is like this or like this, you can demonstrate, you can do it, it will work out, no problem. But very basic testing of physics is like this. You show some small demo and ask a question, and your talent will be tested by your answer. Not only answer, your logical reasoning behind it. Logic, not only answer. Sometimes by luck, answer is correct, but understanding is not there. So I want you people to develop your logic and understanding. Okay? Now, but next question. That is difficult to answer, but let us try. I keep the distance of 2 centimeters. Okay? I keep the distance of 2 centimeters. And then blow the air between the two. What will happen? No, now wicket is gone. People don't answer properly. I have taken 2 centimeters away. Now I blow the air. What will happen?
Sir, it still
The balls will go away, or nothing will happen, or they will come near.
so it will come near, but the intensity will be lower.
Huh?
Intensity will be lower.
Yes?
Intensity will be lower.
Intensity will be?
Decreased.
Okay, then you give me the answer. What will happen to ball?
It will come near.
They will come together. Let us work out. That is physics. Very carefully, yeah? What happened? Now tell me why.
Yeah, but the intensity was lower.
Pressure was
Pressure.
Nothing happened. Why?
The pressure was low.
Now Bernoulli is not applicable. I will not give the answer. You think about it. I leave it to you. I always leave the patients pondering upon. अरे मला खाली गेलंय. This is one of the wonderful experiments I done. I like this very much because it gives the essence of mechanics. Very nice experiment. I got a wooden plank with hook. I got a hammer, very heavy, bulky hammer, strong hammer, with some loop metal. I apply this support, and I keep this on the stand, and surprisingly, the hammer is balancing itself. Oh, great! The hammer is balancing itself. What a great magic, you know. The plank is horizontal, hammer is tilted, heavy mass is here, light mass is here, and is remaining horizontal. Some science is there behind it. Then some science is there. Are you getting my point? You know what I done? Support. Okay. Now, real magic starts here. Real magic starts here. I pull this plank towards my right by distance of 1 centimeter. I got marking here, 1 centimeter. Okay, I pulled 1 centimeter away. Still it is not falling. See the magic. I pull 1 more centimeter. Okay. Great. 2 centimeter I pulled. It is not falling. I pull half centimeter more. Now it is on the edge. And now it is on the verge of falling. But still not falling. Now I depress one end. I see the hammer is wobbling like a pendulum, oscillating, but not falling. Tell me what is physics behind it. Try to answer my question. What is physics behind it? Why the hammer is not falling? Somebody is saying center of mass, correct? Who is saying that, please? You are saying student? Teacher is saying, okay. Now teacher, I'll ask the question. Tell me where is center of mass?
Where the whole mass of the body is supposed to be concentrated.
Here where it is?
At that hook.
At that hook? This hook?
No. At the thread.
At the thread? No.
At that edge.
Yes?
At that edge.
At the edge? Here? No. Here? No.
Sir, on the line, center.
Where? On which line?
So on which the plank is set.
Plank is there. On line, which line? Okay, I'll give the answer. Actually, your answer is correct, but exactly pinpoint is that the center of mass of this complete system is vertically below this edge. Vertically below. I can balance on my 2 fingers. Great. Balancing on my 2 fingers, it is because here is center of mass of the system. And this center of mass, if it is in the plumb line, it can balance. Remember rule. The rule says that if the center of mass is in the plumb line of the support, then balance is there. And about this plumb line, the hammer will oscillate like pendulum because center of mass is below. So this is very important. Our BSc students also, they never understand concepts of center of mass. I have done some more wonderful experiments on center of mass. I'll show you the joker and then other thing. Yes, okay. See this center of mass. I had one idea. I remove this hammer plank and I make this hook tied by rubber band here. I got hammer only. Now I have removed this. This part is removed. And now I have a question. Tell me, where is center of mass of this hammer? Tell me where is center of mass?
On the TIRO.
Yes? Some people say here. Some people say here.
No.
Some people say here.
Somewhere in between.
Where?
In between the iron and
In between the iron and
the white strip.
this.
Yes.
Here.
Somewhere.
Okay. Those who want to learn concept, they can understand my balance. I am balancing the hammer on my finger. On my finger, balancing hammer. That means center of mass must be somewhere above my finger. My finger is in the plumb line. Are you using your understanding? Remember, center of mass is very important. In the universe, everything goes on center of mass. Even moon and earth system, center of mass. Sun and earth, sun and Jupiter, center of mass. You learn lot of astronomy and astrophysics, but center of mass is concept, basic. Now I'll tell you what my experiment, where I done extensive study on this. I got a simple novel method to find center of mass of the hammer. What is this? Plumb line. You have a support, and from this support, put the plumb line, it will come down like this. So the center of mass of the hammer should be somewhere on the plumb line. Yes or no?
Yes.
At least that idea should be clear. It should be on plumb line. But on that plumb line, there are millions of points. So where is center of mass? I have got a very simple idea. And the trick is simple. What I do is that I take one magnet, I suspend a hammer by this. Yes. I got a magnet, I got suspension, and I make a plumb line. And my plumb line goes like this. So if I can imagine that plumb line going like this, it is passing somewhere here. Or if I suspend hammer by this end and again put the plumb line, it will pass through the same point. So these three plumb lines will intersect in one point. And that point is center of mass. I hope you are able to understand.
Yes, sir.
Are you getting my point?
Yes,
Very
sir.
basic. Hammer suspended like this, or like this, or like this. Three plumb lines will pass through one point, and that is center of mass. Now, I'll prove it is center of mass. How to prove? I know location of center of mass, so I dug the hole by drill machine, and through this hole, I pass a screwdriver and allow the hammer to. Oh, great! It is going all round. Now tell me why it is going all round? Because it's center of mass. But difficult concept is that moments are balanced. And what is moment? Mass into distance of all particles summation, sigma, mi, ri. Have you studied about this center of mass? So 11, 12, are they aware of center of mass? Sigma, mi, ri? No.
Only definition.
Only, okay, fine. So they learn in 12th or higher level. Be prepared for next year. Remember one simple thing. Mass into distance. Every particle total on this side and total on this side should be equal. Now, instead of taking, this is center of mass, so the balance is everywhere. It can stand vertical, it can stand horizontal, it can stand any steady state position, right? No problem. But I dig the hole somewhere away from center of mass and tell the hammer to go round. It doesn't. Tell me why. Now the hammer is not going round. Tell me why. Because it is not
Center of mass.
moments are not balanced. Balancing moments is very interesting. Okay? Same thing I am showing you with the help of another motivating experiment. Very special experiment. I want a dancing joker. I keep it on the table. It is balancing. Oh, this is wonderful. The joker is balancing. Can you see there? Yes? Or shall I raise the height? Raise the height, come on. You should talk immediately. Why you keep silent? Yes? Can you see that Joker is balancing on the top of the bottle? And if I tell to be horizontal, it remains horizontal. I leave it. Oh, great. It comes up and balances. Okay. Now I tell the Joker to dance on one leg. Okay. It keeps on dancing. See this? It keeps on dancing on one leg. If I tell the Joker to stand on one leg on a vertical lead, it will stand on one leg. Oh, great. It is standing on one leg. It can stand on other leg also, no problem. It is not falling. Now I tell the Joker to take a round. It is going around. It is not falling. Now tell me why it is not falling. I like people who laugh, you know. They have expression, yes. Something happened funny. They should laugh. You know, those who laugh, they know how to enjoy the life. Yes. Yeah. Anyway, now tell me, it is balancing without any problem. Are you able to understand what I say? Now my question. I want answer with some logic. My question is, where is center of mass of this Joker?
On the leg.
Where is center of mass? Nobody is able to visualize, eh? Nobody is able to think also, where is center of mass? Yes, please. बोल कुछ भी बोल रॉन्ग चलेगा.
सर वो जो लाल ढक्कन रखा है उसके ऊपर उसको
लाल ढक्कन के ऊपर, नो रॉन्ग. नीचे, नीचे के ऊपर. Where is center of mass? Okay, I'll give you some answer. Many students give the answer, wrong answer. Some people say center of mass is between the two balls. Here. Some people say center of mass is between the two legs. Here. Oh, really? It is balancing on my two. On my finger, it is balancing. So center of mass must be between the legs. Wrong answer. Wrong answer. Center of mass is not between the two legs. Now it is balancing on one leg also. Where is center of mass? Below this leg? No. Now it is balancing on this leg also. Where is center of mass? You are not getting the answer. I will give the answer now. Answer is very easy. The center of mass is here. Can you visualize? Can you imagine this point? My finger here. Here is center of mass. Now people ask me, how you guarantee this center of mass is here? The answer is that because it can balance on my two fingers or it can balance on my one finger, but when it balances on one finger, it's tilted because center of mass is here. So the rule says that for the body to be in equilibrium, center of mass must be vertically below in the plumb line of the support. I repeat my statement, very important statement. If you want the body to be in equilibrium, center of mass must be vertically below in the plumb line of the support. Now, I made one simple addition, modification, where I am showing the students interesting method to locate exact position of the center of mass. How to locate? I I got some simple addition here. One addition is one hook. Thread is there and hook is there, and I got one plumb line. Can you imagine plumb line? Yes. Take any pendulum and hang it by thread with rigid support. It is plumb line. Actually, plumb is heavy, bulky, but I have taken small plumb. Okay. Now using this and this, I locate center of mass. That is my specialty. How I locate? See what I do. I hang this joker with the help of a hook and tell the joker to remain stationary. Okay. Now I imagine that the revolver. Now I tell. Now I tell to drop a plumb line down this hook. Yeah. Okay. Now what I done? I drop the. Okay. Make it steady. My assembly suspend by hook, drop the plumb line, and now I say guarantee that center of mass must be somewhere on the plumb line. Agree? Yes or no? It must be, because I have suspended by this point. By this point, any point you suspend, plumb line passing through this is having the center of mass. But now, on this plumb line, there are n number of points, no limit. But I can suspend it horizontally, and then we can see that the suspension by horizontal is giving us a beautiful feeling that center of mass is full. Can you imagine? Plumb line is passing through this point, Imagine point of intersection of the two plumb lines, previous plumb line and this plumb line, where they will intersect between this. And by symmetry, I can give the guarantee that center of mass is here. I hope you can get the essence of this experiment. And center of mass is below my two fingers or below my one finger, yes. And that is science behind this magic. There is no magic, it is just physics, but it is mechanics. And where we learn techniques of measuring center of mass, finding center of mass. I can make on by a switch. Can you see the tube light on?
Yes. Yes.
It is mercury tube.
Yes.
Making mercury on you require very high voltage discharge. But this high voltage is generated using 12-volt power supply and some circuit, Tesla coil like. Okay? And this is one switch on off. And this is source of light, which is element, line source. And if I have element source of light, discharge, if I take the spectrum, you know what is spectrum? Color separated, wavelength separated. And this spectrum of an element is line spectrum. You know what is line spectrum? Beautiful color lines are seen. And these color lines are seen here with the help of simple diffraction gradient. You can hold it. एका वेळेस सगळ्यांना दिसणार नाही पण मी एकेका दाखवतो सेक्शन हिच्या समोर पकडा आधी आधी इकडे दाखवा ह्या कोपरे मल्टिपल कलर्स अँड दिस साइड and blue violet also there. So the beautiful, yellow colors are seen because this is a line spectrum and the colors are separated. But if you are a good observer, you can observe the first order and second order on the same side. Can you see the same side? First and second order, yes. What is the difference? First order is bright lines and second order is faint lines. So the bright lines and the faint lines, they are first and second order. And this is called as diffraction grating. And the diffraction grating is a thin film having plenty of lines per millimeter. How many? 1000 lines per mm. In 1 mm, there are 1000 vertical lines. Very difficult to make such thin film. It is imported. It is made in America, USA, and this is possible only because of special polymers, plastic, very special plastic using some technique of generating lines. Okay? Remember this color. What is this? Mercury. And we can see the beautiful colors. You can see the first order, you can see the second order, and you can see the beautiful color lines, and these are because of line spectrum given by the element. This is element mercury. Okay? Everybody? I am having water, air, laser pointer, and it goes straight line. You can see the laser beam going perpendicular, coming out perpendicular. It is called as normal incidence. Normal means perpendicular. And ray comes like this and goes like this without any change of direction because it is normal incidence, perpendicular. But instead of normal, I make the angle of say 10 degree here. I'll observe that there is about 12 degree angle. So this is small and this is big. If I make this 20, I get around 26. If I make this about 30, I get around 40. Now my question is, this is angle is 30 degree and that angle is 40 degree. Why difference here? Because
Angle of incidence.
yes, it is refraction. It is called as refraction. Now what happens in refraction? When a ray of light travels from denser medium to, it will bend away from normal. It will turn, change the path in direction away from normal. And that is why this angle is small and this angle is large. Now if I make this angle say 40, I get this around 55 to 60. So okay, I am getting around 60. Are you getting my point? 40 to 60. Then I make this angle say 48. I can see this angle is becoming big, and for 50 it is almost 80, 85. See? So this angle is small, this angle is large. If I go on increasing, a stage will come when this angle will become 90 degree. And when that becomes 90, this angle will be called as critical angle. How many? No critical angle, raise your hand. Very good. You have studied physics at school level. Very good. Thank you. I like this response. You know critical angle. Now critical angle for water air is about say 48, 49. Okay. And if I make this angle more than critical angle, I find that the ray is coming back to water and nothing is coming in air. You know why? Yes, it is called as total internal reflection. Wonderful phenomenon. A gift of nature to a human being, total internal reflection. Why total internal reflection? Because all energy comes back to the same medium, it is total. Like total solar eclipse. Total means 100%. Can you see? This ray is coming from water back to water. And if the level is perfect, 90-90, that this symmetry will be there. But some mistake is there in water filling. Let's forget about it. Proper symmetry should be there. And proper leveling should be there. I have not done leveling. If leveling is not done, one side down, one side up, angle will be wrong. In lab, we can do leveling. and we can have perfect symmetry also. But I make it more and more angles, say 70, I get 70. I make 80 here, I get 80 here. So this angle and this angle are same. Angle I is equal to angle R. What is this called as, reflection. And why it is called as total internal reflection? Because total means 100% and internal means no change of medium. Medium is not changed, same medium. So it is internal. And why reflection? Because it obeys laws of reflection. The first law is angle I is equal to angle R, and second law is incoming ray, outgoing ray, and normal. They lie in one plane. Are you able to understand my words? Incoming ray, normal, and outgoing ray, they lie in one plane, vertical plane. Now, I ask you a simple question. If possible, answer quickly. What do you understand by normal? Normal. Yes?
Perpendicular to the
line,
Line, correct?
a line between incident ray and reflected
A
ray.
line between incoming ray and outgoing ray is called as normal. Okay. Any other answer? Yes.
the line perpendicular.
Any other answer?
It is perpendicular.
It is perpendicular. Okay. Any other answer? I am not satisfied. Yes. Any other answer? If you want satisfactory answer, I will give answer. Normal is an imaginary line. Imaginary line. Remember this word. What is normal? Normal is an imaginary line which is perpendicular to the interface. Perpendicular interface and drawn at the point of incidence. Oh, that is very important. Very important. It should be drawn at point of incidence because you can draw the normal anywhere. You can draw here, 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 anywhere. But I am interested in only one line, which is at the
Point of incidence.
point of incidence. That is why scientific answer is. So, will you remember what is normal? Yes. Normal is an
Imaginary line
imaginary line drawn perpendicular to the
of medium
interface at the point of
incidence.
this is correct answer. Okay. Now, how you measure angle of incidence? It is angle between incoming ray and normal. I. And how you measure angle of reflection? It is from normal to reflected ray. So angle I is equal to angle R is one basic school level concept, and that is a reflection. So total internal reflection is very useful in optical fibers and many other phenomena. Have you studied? Have you heard about optical fibers?
Yes, sir.
Vast applications in medical field, telecommunication, and so on. But here, I want you people to understand other way around. If I make the ray of light to pass through the other direction, for example, from air to water. Now what will happen? This angle is large and this angle is small. For example, if I make this 60, I get 40. Why? Because the ray is going from rarer medium to denser medium. It will bend towards. We learn physics at school level, but we never get a chance to observe beautiful phenomenon like reflection, refraction, total internal, partial internal. Now here, when a ray of light is coming here, you can get some ray here. Tell me how come this ray is coming here?
Half of them is reflected upward.
It is reflected, but can we call it total internal reflection?
No, sir.
No, why not?
Half of them has gone up.
Because some energy comes here and some energy comes here. That means there is division of amplitude, division of intensity, division of energy. And this is the beautiful nature property that on the water surface, I can see the beautiful reflection like a partial mirror. So here the water-air interface is playing the role of a partial mirror, and here it is playing the role of total mirror. Oh, ideal mirror. Why? Ideal mirror is the one which will reflect 100% energy back to the same medium. Imagine 100% energy back to the same medium. That is why optical fibers are very efficient, because the losses are minimal. So if the losses are minimized, we get long distance communication possible. Anyway, this is a beautiful demo, one of the best of my own creations. I'll tell you about this in simple. The circuit, the idea of assembly is mine, my own. 25 years back I did it, and I'll tell you about a brief. I did this complete carpentry, assembly, fabrication, total work in my own lab, my own workshop and laboratory, and I have given name to this apparatus. And the name is TIRO. I have given TIRO, SCOP, TIRO, SCOP. How to remember TIRO? TIR stands for total internal reflection. O stands for observation. TIRO. And scope means device. Physics people are very well aware of many scopes. If I go on listing, I got several, but few of you may be knowing this. Telescope, microscope, oscilloscope, stethoscope, gyroscope, electroscope, magnetoscope. Yes, there are, microscope, telescope, they are very common. Electron microscope also is there, but scope, what is meaning of the scope? Word scope is a vast term. Any device, instrument or machine we call scope. Okay, but this gyroscope is my own brainchild, and I had sent this apparatus in one teacher's competition for innovative experiments, and that was Haribhai Mote award I got for it, and that award I got at the hands of Dr. Vasantrao Govarikar, ISRO chairman. It is my fortune to get the award at the hands of Vasantrao Govarikar, and that is 25 years back. It is 25 years back, and I have given many copies of this in many places. I made small copy also. Instead of green leather, I use the red leather, and very compact folding copy, and it is very useful to study all phenomena property. Okay, so here you can see the partial reflection also here, total also, and angle I, angle R. What is the beauty of it? Have you heard the name of Arvind Gupta? When Arvind Gupta came to my house and he saw the experiment, he said, Chakradeo, you have done wonderful work. And what is wonderful? Up till now, we never had the idea that we can measure the angle directly and we can take readings. That means you can do quantitative experiment. Yes, in physics, it is very important. If you can take readings and plot the graph and some calculation, that will be concrete understanding. So, gyroscope and many more instruments are there. I'll show you some more also. But this instrument is bit costly. To make such instrument to require about 3,000 rupees. But I have made it low cost, small, compact, acrylic folding, and that is about 600 rupees. Very red leather. This is green leather, it is very costly, but that red leather is cheap. You can use and you can replace. Anyway, shall I change the experiment? Did you like this? Yes, sir. Yeah. Yes. Okay, now I will start with the demo. You are in a very special globe called a plasma discharge globe, and I bring the tester near it. I can see my tester is glowing without touching, also it is glowing. You know what is meaning of glowing tester?
Yes, sir.
What is meaning of glowing tester? Yes.
Presence of electricity.
The tester glows means there is very high voltage or current and dangerous. So if you will touch here, you will get shock. Yes or no?
Yes,
Yes. But I can do magic. I can touch. I can get no any shock because my body is specially made for conductivity. You know. Yes, I can touch. You see, 1, 2, 3. I am conducting the charge. I am collecting all the spark in my body and taking it to ground. Very special magic. Huh? Yes, if I touch it here, now I show you magic. I am holding the tester by metal and it is glowing. So people are how tester glows without metal towards the source of energy. That is what is science. Okay? I'll tell you the reason of this approach, but I'll show you something more interesting. If I have a tube light, you know what is this? Really it glows. Wonderful white glow. Huh? And I can make the half tube light also to glow.
Mood.
Yes, I can make half. My body has shading effect. This is nothing. I have got wonderful tube light which is glowing with ultraviolet rays. You know ultraviolet?
Yes, sir.
You know ultraviolet? They are very, very dangerous to human eye. If they enter your eye, it will become blind. Now people say, how you glow ultraviolet tube light? I have got ultraviolet tube light and I am glowing ultraviolet by low energy. Low energy means it is not ultraviolet, it is bluish glow. Can you say the bluish glow? Yes. Can you see the half glow? Oh, wonderful. So this is ultraviolet. In water purifier or sterilizer machine, these tubes are glowing at high energy. They radiate lot of ultraviolet and they kill the bacteria. They kill the viruses and they are very useful for sterilization purpose. But this tube light is not to be used outside. It should be in the pack condition. But I have taken it out and I am glowing by plasma and that is my innovation. And this is beautiful addition. Another addition is that I am having the rarely seen tube light. Actually, this is not tube light, it is LED. You know what is LED? Light emitting diode. And I can make this tube light cover removed. I remove the cover and fantastic glow that LED also is glowing. Oh, can you see the LED glowing? Now people ask how LED can glow. Answer is for LED to glow you require very small current and that current is coming here by induction, electromagnetic induction, and the energy source is plasma glow. And this is one of the best possible demo where I can show you that the bulb, a small bulb in my hand, this bulb is also glowing. You can see the bulb glowing. Beautiful. It is neon bulb. Even a small tube also can glow in my hand and that is called a neon tube. Yes, it is neon tube. It is very small tube, compact. I can have another bulb which is big size and wow, very special neon bulb, grand. And I will show you a bangle and this bangle is glowing with beautiful green color. This is fantasy. Green color. Now why green color? Because it is having chlorine gas inside. And chlorine will give discharge of green color. Chlorine. Remember the word chlorine is poisonous gas. Very dangerous poisonous gas. But a chlorine filled at low pressure. So there are so many things to show. I have shown you a few, and people ask me the question, light on me. People ask me the question, you are showing the experiment, but you are not telling science behind it. I want to tell you science. Okay? What is science behind it? This globe is a glass globe, glass bulb. Inside this glass there is vacuum, very high quality vacuum. And in the vacuum, mixture of helium, neon, argon is filled at very low pressure, 1 or 2 millimeter of mercury column, very low pressure. So when you are filling the globe with mixture of inert gases in huge vacuum, and you are having electrode in center, and that electrode has two things. Number one, high voltage. Number two, high frequency. High frequency AC. Alternating. Now people ask how much high voltage? About 10,000 volt. And how much high frequency? 30 to 40,000 cycle per second. So 30 to 40,000 cycle per second frequency, high voltage. Now again they ask how you generate this voltage. The answer is inside this box. There is one circuit called as Tesla coil. You know Tesla coil? Tesla was the first scientist to imagine radiations in space. And there are plenty of things to learn about Tesla coil. Here we are having a very special device. Remember three things. Number one, high vacuum. Number two, low pressure gas mixture. Number three, high voltage and high frequency. So if you are having all these conditions, then what we get inside is plasma discharge. And plasma discharge gives emission of light, and that is seen in the form of sparks. And these sparks are coming to the surface, and they are depositing charge on the surface, and surrounding air will play the role of second electrode. You cannot imagine how surrounding air can play the role of second electrode, because this is called a single electrode discharge. Single electrode discharge. Imagination, very difficult. Only Tesla could do it. He was having idea of making a tower and giving free energy to all, distributing free energy to all. Could not get success, some reasons, but there are plenty of things to learn from net. You can search on net about Tesla and his contribution to science, but he has done tremendous work in physics. Tremendous. Even beyond Edison. Thomas Alva Edison, beyond Edison, he was first person to explain the advantage of AC, main supply, not DC, AC. People never learn proper things from net. I want you people to learn net properly. Learn from net, okay? Now I want to show you one addition in my experiment, and that is my contribution. I got aluminum foil, and I put this foil on the top and fold it to form an electrode. Yes, I am making second electrode now, but this electrode is not having any supply even. And if I make this on, okay, I am making on. I want one or two boys come here and stay. Come. Okay, come this way. Yeah, welcome. You have this plasma on. You can touch here. Are you getting shocked? No. Spark is coming. Okay, you are conducting. So you have no special body. I got same conducting body. Okay. You also touch. Okay. Right? No problem. Huh? No danger at all. But now you have change. Huh? Understand? Bring your finger like this and touch. What am I? You are getting current? Yes. Touch, touch. Now you do one thing. Listen. You touch and touch the finger and keep it pressed lightly. Keep it pressed. Keep it pressed. Are you getting shock? Remove. No, again. No shock. No. Then how you got this one? Now you bring and touch lightly. Don't touch, keep it away. Yes. Bring it here. Surprising. Tell me what is this? Why? जरा लाइट ऑफ करें इनको असर बहुत वर्णला अंदर 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 है मशीन करना टच कर या दोन या पुढे हात वर केला मला या अरे वा दाबून ठेव आहे की नाही अजून नाव यू टू सर्च लॉजिक वाय नेहमी डेमो असताना सगळ्यांना दिसेल असं डेमो करायचं अरे किती स्पार्क येते बघा बोटर ब्युटिफुल स्पार्क बट कीप इन टच नो करंट टेल मी वाय No idea? Okay. You have to search the reason. You have to find out the reason. Okay? Okay. Anybody? Yeah. I'm having special device. This is circuit of LED. LED light emitting diode. And the moment I keep this in water, within 1 second, this water will start boiling. You can see the boiling water. 1, 2, 3. See, it is boiling. See, the water is boiling. Oh, really, it is boiling. And now, if I put my hand, very, very hot. Tremendous hot. Dangerous. Do not dare. Don't dare to put your hand in boiling water. But I have got willpower. I can put my hand in boiling water and take the machine out. See the willing power. My willpower. 1, 2, 3. Very special, huh? Very hot. See this boiling? Really boiling. Oh. Steam coming out. Many people don't believe me. I tell something and they say no, no, not possible. There is no any machine which can make the water boil within 1 second. Because for boiling you require a lot of heat.
Yeah, 4,000.
You know what is this? Anybody has idea? What is this machine called as? Anybody? Have you heard about it? No idea? Okay. This is called as ultrasonic atomizer. This is called as ultrasonic atomizer. And why ultrasonic atomizer? Because inside this machine, I am putting my hand here. One oscillator is there, oscillator, vibrator. And that vibrator is making this diaphragm or membrane to vibrate with very high frequency. And the frequency is so high that we can't hear it beyond audio limit, 20,000 cycles per second. So it is something like 25, 30 and higher kilohertz. And that is making vibrations in water. And the vibrations will make water molecules to separate and jump, and we get evaporation. And what you are able to see here is not boiling, but it is called as evaporation. Okay? So this evaporation is basic phenomena which is having dependence on energy supply, and the energy supply is coming from inside this circuit. Inside this there is one circuit which is energy supply, and it is making the membrane to vibrate, oscillate with high frequency beyond audio. We call it ultrasonic atomizer. Okay, tomorrow I am making a show for the students of degree college, and some experiments will be different and some will be common. So I want those who are really interested, they can attend, but you need not attend all the experiments you should. You do your studies, your work, your rituals, but those who are deeply interested and want to learn more, they can come and join. नाहीतर जागा पूर्ण नाही तर हॉल पूर्ण नाही तर त्यांना मागे बसा जागा नाही. डिग्री कॉलेजला किती मुलं आहेत? 101 मुलं आहेत ना? 100? मग ते सगळे येतील ना उद्या? मग त्यांना बसा जागा नाही मिळणार मग?
होईल होईल
सगळ्यांनी कसं
सगळे नाही याच्यातले इंटरेस्टेड
हा इंटरेस्टेड का नाही? ओके. नाही काय परत बघण्यामध्ये तशी काही मजा नाही आहे. नवीन प्रयोग सगळे नाही, काही नवीन आहे. ओके. एक स्पेशल मशीन आहे माझ्याकडे. एक दोन मुलं आहे पुढे. ज्यांना जायचे तरी पटकन जा, मध्ये जाऊ नका, मध्ये मध्ये डिस्टर्ब करू नका. यु नो कमी त्यांना काही काम असतील ना, हा ते पण आहे. वी हॅव टू टेक केअर ऑफ देम. ओके. Fine. Okay. You know, our human skin is very special. What is special about the skin? The skin has several properties which are exceptionally good. For example, our skin can sense the touch, skin can sense the temperature, skin can sense water, skin can sense sunlight, skin can prepare vitamin D in sunlight, the skin can sense the air pressure, wind. There are so many things, but one property which is very interesting is that our skin can sense electrical charges. Our skin can sense electrical charges, and sensitivity depends upon individual. Everybody has different sense. Now, I want to check your sensitivity, and I want to check by a small circuit here. I am giving you to hold in one hand, and in other hand you take. And I have given you two electrodes, and I am having a circuit which is using power supply, two cells of lithium-ion batteries, and one transformer, one switch, and chain of resistors. I make this switch on off. When I make on off, you can feel a light electrical pulse. It is called as electrical stimulation. I am giving you stimulation. Can you sense that? Let us check your sensitivity. Huh? Yes, you are able to sense. Good. So you are able to sense the current. Some current is going. Okay. Now I am making slightly more current increment, and that is by reducing the resistance. Now instead of here, you can feel current coming up to knuckles. Okay? Yes. Now slightly more, you can get a sense up to forearm. Yes. Now you can sense up to your elbow. Yes. Now you can sense your shoulder. Really? Okay. Now you will feel your collarbone. And now you feel very nice pulse. Yeah. See the reflex. But you are very good in conductivity. Nice. What about you? Let us check your conductivity. Now, one interesting thing is that let's hold it. Ready? Ready? Good. Very good. More, right? Still more. Okay, still more. Now, you are getting? Yes. That means your body is conducting, and you can feel the pulse going in your body. And suppose I give only one wire and give the pulse. Not getting. I give one wire and give the pulse. Are you getting? No. No. Now you hold hands. Oh, now you are getting. How? Tell me why. Because circuit is complete, conductor connected in series. I have done series connection, series. And if I make the connection of 5, 6, 10 people, they also will make the same calculation, and that is the beauty of this experiment. Because I am showing you current pulse, very small current, okay? Getting? But see the difference. His hand is shaking more, and your hand is shaking less. Because he is more sensitive. You are less sensitive. Every individual has a difference. Some people have good conducting body, some people have sensing body, some nervous system. Yes, this is used in medical therapy called as electrotherapy. It's called as electrotherapy. Now people ask me, where you use electrotherapy? For example, suppose you are having some elbow pain, this pain is here. I can wait one electrode here, and give a pulse. So by giving the pulse, I can make this a painkiller. Yeah, this is painkiller. Now giving the pulse means I am improving your blood circulation. Yes, activity, blood circulation. And some people have backbone pain, some have shoulder, frozen shoulder, so many things. And doctors will give advice, but there they are using different frequencies, different voltages, signal, strengths, and there are plenty of things around it. If you go to internet and search for the electrotherapy, you get a lot of information. It is one simple machine I made, and using this circuit, I am making the pulse generator. And you know what is this? Off. It is bell push. And what is this? Transformer. But this transformer I am using as step up. Why step up? From low voltage to high voltage. In our power supply, we use step down from high voltage to low voltage. But here I am using it reverse. So what I do in primary, I make on off current. DC on off. And then I make on off because of mutual inductance. Secondary will generate a pulse. And that is high. And that high pulse, about 100 volt, 125 volt, you are passing your body. And you are getting the sensitivity. Okay? Anybody want to check? Girls, anybody want to check sensitivity? No? Yes? Anybody want to check your sensitivity? No? They are afraid. Huh? Yeah. Yeah, वरती बघा हे एवढा उत्साह आहे. I want to check your body. Good. हो. फार भारी सायन्स आहे एकदम. फारच भारी सायन्स आहे. मी वापरलंय प्रोग्राम स्टुडंटसाठी सांगितलं. फर्स्ट नाही बघा. अरे दोन्हीकडे थोडं वाढलं, थोडी इंटेन्सिटी वाढेल. आता मी काय करतोय, रेशन कमी करते. आता स्टेप बाय स्टेप आपण एल्बो, शोल्डर जाणवलंय. आता आणखी मला पुढे आता एकदम हायएस्ट पल्स येतो. नाव यू आर गेट. या आता तुम्ही बघितलं का हे सरांचा हात असा हालला बघा, त्याला काय म्हणतात ते रिफ्लेक्स. हा रिफ्लेक्स काय असतो माहिती, सडन रिस्पॉन्स. ऍक्च्युअली वेन यू गेट ए पल्स, it goes through your nervous system to the brain, and the brain will give the order to. But sometimes without reaching the brain, on the path decision is taken. That is reflex. Wonderful. You search on internet what is meant by reflex. You will get beautiful information. Yeah. Right. ओके, थँक्यू व्हेरी मच. अरे या आत्ता येते तुम्ही, मी वाट बघते कोणी येते. या आधी कोण घेते तुम्ही एकेका. आपण खाऊ खायचं ना, एकेकाने खायचं. बारीक आहे काय, दोघांनी. अरे सेन्सिटिव्ह किती आहे बघा. आय गेव स्मॉल पल्स अँड शी इज मेकिंग व्हायब्रेशन. अरे बाप, भयंकर सेन्सिटिव्ह आहे. हा आता पुढे, आता मजा बघा. वाढलं काय, घाबरू नको काय, मी गॅरंटी देतो. तेव्हा ते हात बघा तिथे. लेडीज आर मोर सेन्सिटिव्ह. नाव यू कॅन शोल्डर. आता बघ या कॉलर बोन कडे बघ. अँड नाव यू कॅन सी हर डान्सिंग. येतो डान्स कर ना, तेव्हा डान्स करते आहे ना भाई. धर्म अरे एकदम जॉय जॉय खूप कमी आहे हरकत नाही युअर स्ट्रॉंग आता बघ अरे पुढे पुढे हात हात या मुलाला अरे आता डान्स करणार तू अरे हात बिंदास पकड काय होत नाही तुझं हे काढलं का इन्शुरन्स वगैरे नाही इन्शुरन्स काढलं पाहिजे बारीक आहे ना विचारलं एकदम बारीक आहे ना मोर सेन्सिटिव्ह हात लांब ठेव अरे माय तू बिंदास आहे घाबरली काय होत नाही काय होत नाही काय होत हे बघ तू डेअरिंग बाज बन एल्बो एल्बो आता शोल्डर शोल्डर बघा हे बघा असा डान्स अरे किती छान डान्स करते ओके आता मी काय करणार आहे मला असं म्हणत आहे की मुली या नॉर्मली जास्त सेन्सिटिव्ह असतात मुलांपेक्षा काय माहित नाही मला आय डोंट नो मेडिकल रिझन आहे बायोलॉजिकल आहे जेनेटिक आहे काहीतरी आहे पण मी असं पण बघितलंय की काही काही मुली मुलांपेक्षा सुद्धा कमी सेन्सिटिव्ह आहेत स्ट्रॉंग आहेत अँड दे कॅन स्टँड फॉर हायर शॉक तर मी सगळं असं म्हटलं की मला 5 मुलं आणि 5 मुली इथे एका ग्रुपमध्ये पाहिजेल आहे आणि त्या सगळ्यांना एकच पल देणार आणि प्रत्येकाची रिएक्शन बघणार आणि मग त्यांना रँकिंग नाही रँकिंग सेन्सिटिव्ह 1 2 3 4 बघा 5 मुली आणि 5 मुलं इकडे 5 मुलं या 1 2 3 4 5 आपण टेस्टिंगला 5 घ्या 5 घ्या 5 काय म्हणजे नंतर वेळ तुम्ही 5 थांबा मी काय करते बघा हे मी काय करते बघा हा जो आहे ना ग्रुप त्याला मी टेस्टिंग कसं करते बघा मला 5 मुली 5 मुलं एका साईडला नको आहे मला अल्टरनेट मुलगा मुलगी पाहिजे तर मी सांगतो तुझा ऐका पटपट हा तू इथे उभे राहा तू इकडे इथे वर तू इकडे तू इकडे तू इकडे तू इकडे किंवा इकडे आता बघा काय अल्टरनेट मुलगा मुली आता तुम्ही काय करायचं एक चेन बनवा चेन साखळी हा आणि चेनचा एक टोक आणि हे एक टोक माझ्याकडे या म्हणजे असं जवळ आहे हा चेन हे प्लग आहे आणि हे प्लग चेनचं एक टोक काय होत नाही असं बनवायचे मला अल्टरनेट मुलगा मुलगी पाहिजे कारण मला कनेक्टिव्हिटी बघायची हा आता कोणाचा हात झाला की शॉक बसतो मला माहित नाही. बघा रेडी, मी एकच कॉल देतोय, तुझ्यातला हायेस्ट सेन्सिटिव्ह कोण आहे ते मला कळेल. फक्त मी एक नजर टाकतोय आणि बघतोय. बघू ना, थांब. रेडी? हायेस्ट सेन्सिटिव्ह आहे मी का, घाबरू नको काय. रेडी? थांबा, मी नीट बघतोय.
सवय झाली आता.
रेडी? एकदम सगळे स्ट्रॉंग आहे. जास्ती मुली सेन्सिटिव्ह आहे. तू हलतोय. रेडी? तू गेली.
नहीं मैं तो
Now I am here to give vote of thanks, but I also say, I would say, sir, thank you is not the word, enough word to say. So, sir, give us not only the he has not done only experiments, but he give the life experience of the physics or science. So, first of all, I would like to say thanks to Dr. Chakradeo Sir for giving such a mesmerizing and life experience experiments to us. I would also like to thank CHMB Society and Dr. Principal Sir for giving this opportunity to arrange such a guest lecture. I would also like to thank our HOD Sir, Ikankar Sir, for giving such a experience to us. I also like to thank my colleagues and all my students for इतका वेळ थांबलात तुम्ही आणि इतका आनंद घेतलात तुम्ही लेक्चरचा, त्याबद्दल तुमचे धन्यवाद. थँक्यू सर, जोशी सर.
सर, मला इथे खूप खूप आनंद आला. एवढा चांगला ऑडियन्स मला कधी मिळत नाही बरं का. हाय क्वालिटी, रिअली इंटरेस्टेड आणि सगळ्यांना मन लावून ऐकतायत. मला बरं वाटतंय. 3 तास झाले अजून ते नाही म्हणून थांबच ना पडत. थांबा म्हणत नाही मजा. या यू एन्जॉय.
येस सर.